Hello students, welcome to our student support program for additional mathematics grades 10 and 11. Our topic for today is series and we are looking at the second part of the chapter Arithmetic Sequences. So let us start. In the previous lesson, we have learned how to recognize an arithmetic sequence, how to find a specific term in an arithmetic progression, and how to find an expression for Tn in an arithmetic progression. In today's lesson, we will learn how to find the sum of the first n terms in an arithmetic progression and how to use the formula for the sum of the first n terms to solve problems involving the arithmetic progression. So a recap on the notations to be used. The first term will be denoted by A, the common difference by D, the last term will be L, the number of terms we are going to use the letter N. For the nth term we use Tn, and now we are going to use Sn to denote the sum of the first n terms. Let us try to derive the formula for Sn. You will recall that T1 is A, T2 will be A plus D, T3 will be A plus 2D, T4 will be A plus 3D, and so on. The expression for Tn was A plus n minus 1 into D. Now, let us have a look for S1. S1 means the sum of the first term. That is, S1 will be equal to T1, which is equal to A. Now, S2 means the sum of the first two terms. That is T1 plus T2, which is A plus D, which gives us 2A plus D. S3 will mean the sum of the first three terms. That is T1 plus T2 plus T3. In other words, A plus D plus A plus 2D, which will give me 3A plus 3D. Similarly, S4 will mean the sum of the first four terms. That is T1 plus T2 plus T3 plus T4. And we replace T1 by A, T2 by A plus D, T3 by A plus 2D, and T4 by A plus 3D. Simplifying, we get 4A plus 6D. But obviously, we cannot keep on finding the different sums in this way. So we come up with the formula Sn, which is the sum of the first n terms, and the formula is n over 2 into 2a plus n minus 1 into d. Now, a quick recap on the formula to be used. So you will remember in the first lesson, we learned that Tn is a plus n minus 1 into d. But now, we are also going to learn that Tn can be Sn minus 1. That is, Tn will be equal to the sum of the first n terms minus the sum of the first n minus 1 terms. For Sn now, we are going to have two formulae. Sn is equal to n over 2 into 2a plus n minus 1 into d. Or we can also use Sn, the sum of the first n terms, as n over 2 into a plus l, where a will be my first term and L will be the last term. So we usually use this formula if we are given the last term. Let us move on to the first example. 5 and 8 are the first two terms of an arithmetic progression. Find the sum of the first 15 terms of this AP. So here's the question at the top. Now 5 and 8 are the first two terms. So here A will be equal to 5 and D will be equal to 8 minus 5, which is 3. Now the formula for Sn is n over 2 into 2a plus n minus 1 into d. And we have been asked to find the sum of the first 15 terms. So in other words, I need to find S15. So here I will replace n by 15, a by 5 and d by 3. So we get 15 over 2 into 2 times 5 plus 15 minus 1 times 3. Simplifying, we get 390 for the sum of the first 15 terms. Let us move on to example 2. The second term of an AP is 6 and the 10th term is 22. Find the sum of the first 20 terms. So the second term of an AP is 6 and the 10th term is 22. This means that we will have to use the formula for Tn. So T2 is 6, that is A plus D equal to 6, and I call it equation 1. T10 is 22, that is A plus 9D equal to 22, which is equation 2. So we have to solve these two equations simultaneously. So here equation 2 minus 1 will give me 8D equal to 16 and D equal to 2. I substitute the value of D into equation 1 and I get A equal to 4. So now I have to find the sum of the first 20 terms. So I will use the formula for Sn. I will replace n by 20, a by 4 and d by 2. So I get S20 equal to 20 over 2 into 2 times 4 plus 19 times 2. Simplifying, I get 460. So S20 will be equal to 460. Let us have a look at example 3. The sum of the first 6 terms of an arithmetic progression is 48 and the 6th term is 13. Find the first term, the common difference, and hence find the sum of the first 40 terms. So here we have been given the sum of the first 6 terms to be 48. So my formula for Sn is here, Sn equal to n over 2 into 2a plus n minus 1 into d. So S6 equal to 48. Simplifying, I will get 6 over 2 into 2a plus 5d equal to 48, which gives me 2a plus 5d equal to 16. This is my first equation. Now, T6 equal to 13. So I will have to use the formula for Tn, which is a plus n minus 1 into d. T6 equal to 13 will give me a plus 5d equal to 13. This is my second equation. So equation 1 minus equation 2 will give me a equal to 3. Substituting the value of a into equation 2, I will get 3 plus 5d equal to 13, 5d equal to 10, and d equal to 2. Now I need to find the sum of the first 40 terms, that is S40. So I replace n by 40, a by 3, and d by 2 in the formula for Sn, and this will give me S40 to be equal to 1680. Moving on to example 4, the sum of the first 6 terms is 36 and the sum of the first 10 terms is 100. Find the 14th term. So here the formula for Sn. Now S6 is 36. This will give me 6 over 2 into 2a plus 5d equal to 36. Simplifying, I get 2a plus 5d equal to 12, which is my first equation. The sum of the first 10 terms is 100. That is S10 equal to 100. I replace in the formula and I simplify to get the second equation as 2a plus 9d equal to 20. Equation 2 minus equation 1 will give me 4d equal to 8 and d equal to 2. I substitute the value of d into equation 1. 2a plus 5 times 2 equal to 12. This will give me 2a equal to 2 and a equal to 1. So now I need to find the 14th term. So I will use the formula for Tn, and I need to find T14, which is a plus 13d. Replacing a by 1 and d by 2, T14 equal to 27. So here are a few exercises for you to practice on finding the sum of the first n terms of an arithmetic progression. So students, in today's lesson, we have learned how to find the sum of the first n terms in an arithmetic progression, how to use the formula for the sum of the first n terms to solve problems involving the arithmetic progression. So students, we have come to the end of the second lesson on arithmetic sequences. Until we meet again, it's goodbye.